Okay, so today we're going to learn about elimination. And just like yesterday, it's going to be focused on solving systems of linear equations. So this forms a line, and this also forms a line. So we're going to solve these two linear equations. Now here's what's different from today rather than yesterday. Today we have the case where x and y are both on the same side. So when x and y are both on the same side, we don't want to use the two other methods. We don't want to try to graph this because graphing this, you can't really graph stuff that's not in y-intercept form. So this is like in standard form, so I can't really graph this. Like graphing's not going to work. And substitution's not going to work because I don't have like y equals something. So neither of those methods would be good. So we're going to go with elimination. Here's how elimination works. Elimination works by adding the two equations together and hopefully something eliminates. So we're going to add these two equations together and we're going to hope that something eliminates. Well, when I do 4x plus a negative 4x, that would become 0x. So it goes away. It's not even like 0x is the same as nothing. And then when I add this together, 8 plus 2y, I'm going to get 10y. Then when I get this, I'll have 20 minus 30, or 20 plus negative 30, and I'll get negative 10. Now the nice part is, once we get to this step right here, we can go through, divide by 10, divide by 10, and I would know that y is equal to negative 1. Unfortunately, again, we're not done, because solving this thing means that I have a y value and an x value. It means I have both. So I'm going to just take that first equation and plug in what I know, which is that 4x. I'm going to just scroll back up for a second. Plus 8y is equal to, I'm pretty sure that was 20. Yep. That was 20. So we now know what y is. Y is negative 1. So instead of writing this the same way, I'm going to write that 4x plus 8 times negative 1, because that's what we found that was, is equal to 20. And we just solve. So 4x minus 8 is equal to 20. Add 8, add 8. 4x is equal to 28. So x must be 7. So that would be my answer. 7, comma, negative 1. Because that's my x, and this is my y. That's one example. We're going to go through two more examples because there's three types that we generally get. This is the type where I can just add straight down and everything cancels out nicely. Okay, so here's the second type. Again, we have things where x's and y's are on the same side. Now the issue with this is, if I was to add straight down, what I would end up getting would be 15x minus 6y, which is equal to negative 9, and I would go, darn it, nothing canceled. I just made another equation that doesn't even help me. So I'm going to kind of erase this, because that doesn't give me anything that I would want. So we have to change one of these equations so that when we add, something will cancel. Now things cancel when they're the same number but opposite. So I'm going to think, how would I make this the same number as this x and make it cancel? Well, if I times this by a negative 2, that should work out. So my new top equation would be negative 10x minus 2y is equal to negative 18. Since we didn't need to times my bottom equation by anything, we just write that to be the same. And now I'm just going to add this straight down. So when I add it straight down, because now they're opposites, those things will cancel. I'll get negative y is equal to negative 36. And when I divide, I'll get that y is equal to 4. Again, that's just one of my answers, so I need to plug this thing in to one of the equations. I'll probably pick this top equation again. Instead of writing y, we'll write 4. So I have negative 10x minus 8 is equal to negative 18. Add 8, add 8. Of negative 10x is equal to 10. So x would equal negative 1. And again, I would write this as negative 1 comma 4. And that would be my final answer. So that's the second type, where you have to take one of the equations and multiply it by a number so that you can cancel these, because you want one number to be the same but opposite. Let's see the last type. Okay, so here's the last type. This is when the numbers, again, if you added them straight down, you wouldn't get anything nice. Nothing would cancel. You get 8 and negative 5. So that doesn't help me. And the other problem is, like, if you can think of a number that when you multiply it by 5, you get 3, or if you could think of a number that when you multiply by 3, you get 5, I don't know what that number is. So, because I don't know what that number is, here's your fail-safe. Your fail-safe is to take each equation and multiply them by each other. So if I take this side and multiply by 3, and I take this side and I multiply by 5, in a second you'll kind of see what happens. Now, it's nice if they're the same, see how these are both positive. I want to make one negative so that I'm sure it will cancel. So I'll make the top one negative. So what would happen would be I would get negative 15x minus 12y is equal to 90. Then I would get 15x minus 45y is equal to, that would be 90 again. Because 5 times negative 18. Negative 90. Good. Negative 90, because 5 times negative give me a negative. Perfect. So now we'll just add these things together. And again, because we times them by the opposite, 3 times 5 is the same as 5 times 3. So it guarantees us that these numbers will be the same. That cancels. That gives me negative 57y. And the nice part is this gives me 0. So if that gives me 0, when I divide both sides by negative 57, I just get that y is equal to 0. And then we got one answer, so I have to get a second answer. I'll just take that bottom equation this time, since it doesn't matter which equation I use. So we'll do 15x minus 45 times 0 equals negative 90. Well, negative 45 times 0 goes away, so you get 15x is equal to negative 90. Divide both sides by 15, and I should get that x is equal to negative 8. And again, we can write this as negative 8 comma 0. Try some of these problems. So again, elimination, we're just going to add the two things together. You want to make sure that one of the numbers or one of the variables is exactly the same so that they'll cancel out. If they're not, you have to multiply the equations by a number until they will cancel.